What's up, amazing people, students, lovers of chemistry, and everyone watching? I'm super excited to begin this series with you today, where we're talking about the concept of stoichiometry in chemistry. My name's David, and I'm a high school chemistry tutor for kids who are in the high school. And we're going to be having a lot of fun in this series, so I want you to sit back, relax, and enjoy every bit of what I've got for you. We're handling this topic by topic. So let's get into what we have for today's video. Now, by way of introduction, let's define what stoichiometry means. And I like to be pretty simple and basic. So stoichiometry is simply the mathematics of chemical reactions. So think of it this way. When chemical reactions take place, we have reactants plus reactants, forming products. Now, you'd agree with me that there are certain amounts of each reactant that must combine together to form a particular amount of products. Now, the mathematical procedure that enables us to attain the exact amount of products and reactants that take place in a chemical reaction is what stoichiometry is. So stoichiometry is simply about figuring out first how much substances that you are starting with, how much products you can produce, how much you need for a reaction to take place, and then how much may remain after the reaction has fully occurred. So think of stoichiometry as the process of doing calculations using chemical equations. So stoichiometry enables us to know the mathematical quantities of substances that take part in a chemical reaction. So moving forward, we need to also understand that there is a particular amount that is needed for reactions to happen properly. And that is why chemical stoichiometry involves calculations. That is why chemistry involves calculations. So through stoichiometry, chemists can calculate the masses of substances, the volumes of substances, the number of moles of substances, concentrations, and even the amount of products formed. You'd hear chemists come out to say something like, we were able to obtain 3 grams of carbon dioxide, CO2, from this reaction. And you'd be wondering, how were they able to calculate that amount? Well, they were able to do that because of stoichiometry. At this point, I believe you're getting value for what you're receiving in this video. If you are, consider liking, sharing, and subscribing to this YouTube channel. Let's move on. One of the easiest ways to understand stoichiometry is to think about cooking recipes. Now, I have an image of a cookbook on the screen right now, and I want you to pay close attention because I'm about to explain a concept. A chemical equation is very much like a cooking recipe. Now, for those of us who do not know, a cooking recipe is simply a written record that contains the ingredients that are needed to produce a particular meal, a particular dish. Now, it doesn't just contain the list of ingredients, it contains the amount of each ingredient that will be needed to produce that particular dish. So a chemical equation works very much like that. Let me explain. We have this reaction on the screen: hydrogen plus oxygen producing water. This is written with English. In chemistry, however, we write it using symbols and coefficients. So we have the symbol of hydrogen, H2, plus oxygen, O2, producing water, H2O. Now, if you pay close attention, you would notice that there are some numbers playing out their parts in this chemical equation. For instance, we have the number 2 standing in front of hydrogen, we have oxygen, and we have the number 2 standing in front of water. Now, if you notice, there are two, or there is a coefficient of 2, which tells us that we have 2 parts of hydrogen. There is no number standing in front of oxygen. However, we know that this automatically means that there is a number 1 there, because anything that goes by itself is 1. So we have 1 part of oxygen, and then we have 2 parts of water. So from this chemical equation, we can safely say that 2 parts of hydrogen reacts with 1 part of oxygen to produce 2 parts of water. That is how this chemical equation can be read in simple, plain English. So that's basically what stoichiometry is all about. It's like a recipe that tells us the amounts of substances that take part in a reaction and the amount of substances that are produced from that reaction. Which brings us to the concepts of chemical equations. You see, chemical equations are so important because before you do stoichiometry calculations, one thing must happen first. The equation must be balanced. You might be asking why. Well, without balancing your equations, your calculations will end up being wrong. Remember, I said chemical equations are like recipes. Now, let's say you have a recipe to make noodles. And to prepare that noodles, you need, let's say, 1 seasoning cube. Now, instead of 1 seasoning cube, let's say you added 5. What do you think would be the result? You're going to have an awful recipe produced at the end. Why? Because the recipe you followed was wrong. In the same way, when a chemical equation is not balanced, it means the recipe for that chemical reaction is wrong. So balancing chemical equations help chemistry calculations to make sense. I believe you're getting much value for what you're seeing in today's video. So let's move on and tackle some more concepts. We have some worked examples on the screen. I'll be taking you through them one after the other. So consider this chemical reaction on the screen right now. We have this equation and we are being asked how many parts of hydrogen react with 1 part of nitrogen. Well, let's write out the equation one more time. We have N2 standing for nitrogen plus 3H2 standing for hydrogen and then 2NH3. How many parts of hydrogen, here is hydrogen, react with 1 part of nitrogen, and here is nitrogen. We have 1 part of nitrogen over here because there is a number 1 standing in front, and we have 3 parts of hydrogen over here because you can see the number 3 in front of hydrogen. So the answer is pretty straightforward. 3 parts of nitrogen react with 1 part, or 3 parts of hydrogen, I beg your pardon, reacts with 1 part of nitrogen in this chemical equation. Pretty easy, pretty simple, and pretty straightforward. You see how stoichiometry has enabled us to know the amount of a particular reactant that was needed for the reaction to take place. So the summary of all we've been saying in this introductory video can be basically summed up as this. Stoichiometry is simply the mathematics of chemical reactions. Chemistry uses calculations because reactions involve specific quantities. Chemical equations behave like recipes. Stoichiometry uses ratios from balanced equations. We're going to be seeing all of that as we progress. And then balancing equations come before calculations. And then finally, understanding ratios is the secret to mastering stoichiometry. We're going to be dealing with all of that. We just wanted to break the ice today by learning the introduction about what stoichiometry is all about. So in the meantime, whilst we wait for the next video, let's have some exercise questions that I'd like you to try out your hands on. The first is, in simple plain English, what is stoichiometry? Next is, why does chemistry involve calculations? And then thirdly, why is balancing equations important before calculations? Answer these, drop them in the comment section where I'll be waiting to answer your comments. And I have some more exercise questions I'd like you to handle. The fourth one says, consider this chemical equation on the screen. We have this chemical equation right now. How many parts of hydrogen react with 1 part of oxygen? And then how many parts of water are produced? And then we have the fifth one. Consider this chemical equation on the screen. What is the hydrogen to nitrogen ratio? And then how many parts of ammonia are formed? Answer this, drop your answers in the comments where I'll be waiting to receive them. And I'll see you in the next video where we get to see stoichiometry with chemical equations. Once again, my name is David and I trust you got value for this video. Stay safe till next time and God bless.